I thought building apps that integrates LLM or AI agents will be difficult to implement, but it turns out it's actually a lot simpler than I expected. In this video, I'm going to show you guys how to use Vercel SDK to build AI agents and integrate them into your application. So let's dive into this video. The AI agent that we're building in this video is going to be able to check flights and return the information using an API. And we're also going to be able to use a RAG pipeline to see the reviews that people have on hotels in Montreal. So let's just have a quick look at the agent. So I'm going to go with hey, and the agent replies, how may I assist you? I'm like, flights from Calgary to Montreal. And he asks me for a departure date, and I can just go with 25th August 2025. And then he returns us the flight options from the flights. Then I could ask it about hotel reviews in Montreal. And we're going to use a RAG pipeline to get people's reviews on different hotels in Montreal. Now, so let's see how this was built. So just a couple of things. The main reason why I'm using Vercel AI SDK is because if you look at OpenAI, Anthropic, Grok, Gemini, or all the APIs for you to be able to use your LLMs, the implementation is slightly different. The good thing about Vercel SDK is that it allows us to have all the models in the same place. Before we proceed further, I think that there's some basic things that we need to understand. So we need to understand what tokens are, and tokens are essentially basic units of text for an LLM. So let's say you have, hey, that can be a single token. And sometimes tokens can just be a single word, it can be a punctuation. It doesn't even exactly have to be a specific word, it can be subwords as well. And the other thing we need to understand is context windows. Or context window is the maximum amount of tokens that an LLM can process at a single time. So usually when the LLM model is bigger, the context window increases. And let me show you how this works. So usually in LLMs, we have a system prompt when you're building an AI agent. Let's say you want to focus it on a particular task. Usually use a system prompt to do that. You have message history, which includes all the previous messages. And then you have the new message, which is the current message you're trying to send the LLM. All of these are the tokens you're sending to an LLM. And then let's say this is the context window, maximum amount of tokens that LLM can process. If the number of tokens that you send to an LLM actually exceeds the context window limit, what happens is that the oldest information actually gets truncated, and we just focus on the newer parts of the messages that the LLM is able to take in. So to get started, the first thing we're going to do is come to openrouter.ai, and we're going to get API keys from OpenRouter just by creating API keys. We're just going to come to our code base, go to our .env file. I'm going to enter our OpenRouter API key. And once we do that, we're ready to go. So we're just going to go to our AI SDK documentation, and then I'm just going to copy this. And this is actually everything you need to actually start generating code with the LLM. So I'm going to do this, but we're going to change a couple of things. We're using OpenRouter, so I'm going to make sure we change it to OpenRouter. And then once we've done that, I think the only thing we have to do that's left is we actually have to change this to type model messages. And now I think we should be ready to run our agent. And we go, hello, how can I assist you today? And one thing that's important, I actually changed this from GPT 4.0 to GPT 4.0 mini just for this tutorial because I don't think we need anything much more than that. So pretty much you can ask this AI agent anything you want to ask, and it's basically like just having a conversation with ChatGPT. You can actually make this a lot more powerful by adding tool calls, and we can add long-lasting memories, and we can actually implement a RAG pipeline. But let's first go over the code. We're actually importing the OpenRouter SDK, and we're importing string text from the AI SDK as well. So this block of code here creates an interface for us to be able to have conversations in our terminal, and then we have a messages array, and this array temporarily holds the conversation history. So talking to the agent actually makes more sense. So you can actually remember conversations and is able to respond more accurately. If let's say we didn't have this, you can tell the agent, hi, my name is Scott. And then when the agent responds and it's like, hi, Scott, and then send the agent another message and be like, what's my name? It won't be able to remember. So that's why you kind of need a way to store the message history. So that's why we have these messages. The loop actually begins by us giving the AI agent input. So that is what will happen here. And when we respond to the input, we actually just push the message to the messages array. Based on the messages array, we're actually just going to send all the information to the LLM. And when we send the information to the LLM, we'll get a response. Something to pay attention to is that we're actually streaming the response. So, when you're chatting with ChatGPT and the information is just streaming, you're not just getting a whole block of text at once. So that's what we're doing with stream response. You can actually change it to generate response if you want to get all the information at once. I think I prefer to stream the information. And then this whole block of code is actually just streaming the information to our terminal. And we have a full response variable. And once we get everything, we're just going to push the full response back to the message array to keep the conversational history. Now, a couple of things you want to pay attention to. You can see that we have a role of user here, and we have the content, user inputs, and we have role assistant, and we can see content. And we can see the content, the full response. Now, the reason why I say you should pay attention is that you notice that we have role here. So the way LLMs work and are able to keep track of conversation history is through this role. So when we have role user, the LLM actually knows that, it's actually the user that is sending this message. And when we have role assistant, the LLM is able to understand that, this message is actually coming from myself. So this is how LLMs are able to keep track of message. There's also another role known as system, which is the system prompt I talked about earlier. But we'll dive into that later on in this video. So now let's talk about tool calling. Remember earlier in the demo I showed you guys, you saw that our LLM was able to actually provide you with real-time flight information because I integrated tool calls into the AI LLM agent. Tool calls are essentially when you allow an external function to do something and return the result to your LLM. When you say something, the LLM will be able to infer whether this would require a tool call. And based on that, we get a tool call and we get our tool results. It's fed into the agent and then we get the response back. Let's look at how this was done in our own example. The most important thing you want to do is actually import tool from the AI SDK. You also want to import Z from Zod. The way the tool works is that when we get the tool function, we have to make a description. We'll be able to allow the LLM know whether it's supposed to use this tool call or not. So find flight offers based on search criteria using an API, using the Amadeus API. We also have an input schema. Obviously, to be able to find the flights, you need some certain information, and we're going to use Zod to describe that information. The information is going to be a string, and origin location will actually be the airport we're actually leaving from. We have a destination, we have the departure date, we have the maximum price. And then based on all this information, we add everything and then we make the API call. And then when we make our API call, we're actually just going to get the result returned to us. I'm just going to delete the console log so that when we test it out in the terminal, it doesn't get messy. And then when we get the information from the API call, we're just going to return the information to our LLM. I'll go to our index file. When I go to the index file, remember I talked about system prompts earlier. I told this you're an AI travel assistant that helps with flights and Montreal hotel location because our data set we're using for the RAG pipeline only has information for Montreal hotels. So we also tell the agent that you can search flights using the Amadeus API. But since we're talking on tool calling, let's just focus on this part. So when we're streaming text, we're just going to have a tools object and we're going to import the find flight tool. And once we've done this is all we need to be able to make tools. Now, the next thing we need to look at is bringing long-term memory to our agent. Previously, we were storing messages in an array. The problem with an array is that it's in memory. So let's say we close the program. All our previous message history is actually gone. When you're using a database, the information is actually stored on your disk. So even if you turn off your computer and you come back, or you turn off the program and you come back, the information is actually still there. So that's what we're going to be doing. Now we're going to be using a small database, LowDB. LowDB will essentially allow us to store a conversation in like a JSON file. So let's go and implement this. To use LowDB, the first thing you have to do is npm install lowdb/node. I've already installed it, but you just let NoDB know where your directory is going to be, and you have new JSON file. And then we have our adapter, and then we have default data. This just defines what will be in the database. Let's say we don't have any entries. We use the combination of these two to create a new LowDB class. And for us to be able to read our DB, we can use await.db.read. And when we're writing information to our database, all we need to do is actually just push the data and write it to the JSON database. When you manually change information here, the LLM will just take it as it is. So the LLM will actually believe that it was the one that generated the assistant call. That being said, I just want you guys to see this in action. So when I go to run the information, I can go with hey, and then when we get the response, you see that the message is actually in a db.json file. So retrieval augmented generation, that's what we're looking at. So this allows us to enhance the LLM with external knowledge. So the way it works is that we get the knowledge or the paper that we're trying to show the LLM or the data set. We get the data set we're trying to show the LLM and we pass it through an embedding model. Now, the embedding model is going to actually transform the text into a vector format. And this vector format is going to be stored in a vector database. Now, if you don't know what a vector database is, a vector database exists in a three-dimensional space. Now, you might see something, bananas, green apples, and pears. What do they all have in similarity? They all have the fact that they are fruits in similarity. Because that is the case, their vectors are actually closer. So it actually clusters information based on their similarity. And then we retrieve this information by LLM. So let's look at how this will work. In case we're going to use Upstash as a vector database. I'm going to go to the browser and yeah. So when you go to vector database in Upstash, you click on create index. There's a couple of things I want you to take note of. So for the embedding model, we can actually have a custom embedding model. In fact, OpenAI actually provides you with its own embedding model. All you need to do to use the embedding model is just to add this block of code into your code. But I think Upstash makes it simpler because they provide you with the vector DB and you can actually choose your own embedding model. I'm going to go with the mixed bread embedding model and we use our metric as cosine. So this will perform a cosine similarity search. Now you can name your DB whatever you want, but I already have a database. All you need to do is copy these keys and paste them in your environment variable. I have a data set I got from Hugging Face. It's not the best data set in the world, but all it does is gives you reviews that people had for hotels in Montreal. And then we're going to ingest this information. So ingest means we're going to push this information to our vector database. And remember, we already have embedding models, so it all happens in one step. All you need to do is run node, and then you come into the directory where the information is, and then you're just going to run ingest.tx, and basically we're just going to send this data to our vector database, which is good. Now, if we come over here, we can see that we actually have records in our database. So I already did this previously, but that's where you send the records to your vector database. Now, when you want to query the vector, the important is you need to understand that query and top K. So when you're using what are the best hotel reviews in Montreal, so this will perform cosine similarity search and see all the positive reviews, and then it will return them and spit them out back to you. Top K is the number of relevant records. Since I've talked and explained everything, let's just see how this works in action. I can actually tell them, I can be like, what are the best reviews for hotels in Montreal? And to actually go through the document and to bring the most relevant information. So yeah, we only have 2 positive ratings, it seems like. But then yeah, like the main important thing is that this information, you can't get this information from the LLM, but we're able to add an external knowledge base into the LLM. Now, this is not the best RAG pipeline in the world, but it's just like an intro for you to understand how it works. This is pretty much everything you need to know to add AI agents into your application. Leave a like, comment, and subscribe. Thank you for your time.